welcome to episode 3 of DEITV. I am your host, Salomon Alcocer Guajardo. In today's episode, I'm going to review the probability and logarithm-based indices. Once that is completed, I'll discuss the Simpson diversity indices, which were covered in episode 1. After covering the Simpson indices, I'll review the Smith and Wilson indices, the probability-based and logarithm-based index, which were covered in episode 2. Then I'll go ahead and give an overview of the McIntosh diversity indices, and that'll cover the concentration or similarity index and also the Evenness index. Once that is completed, I'll move on to the application. And in today's application section, I'm going to segment that into 3 sections. The first section will cover the application to the gender-based data that was covered in episode 1 and episode 2 for consistency. Then I'll move on to the ethnic-based data. The third section will apply the McIntosh Evenness Index to the revenue-based data, which was covered again in episode 1 and episode 2, and that's for consistency across all the episodes. Once the application section is completed, I'll review the additional materials, and then I'll move on to a quick overview of episode 4. So stay tuned for the review of the diversity indices. As I mentioned a few seconds ago, I was going to cover the different types of diversity indices. Recall that in episode 1 and episode 2, I listed the probability-based indices. Those include the Holbert, Alcocer, McIntosh, Simpson, Smith and Wilson indices, and the Wilcox index. Recall that the Simpson index, again, was covered in episode 1. The Holbert, Alcocer, McIntosh, Smith and Wilson, and the Wilcox indices are all based on the Simpson index. In today's episode, I'm going to cover again the McIntosh index, which is also a probability-based index, and also is an extension or modification of the Simpson index. The logarithm-based indices include the HYPE or HEAP index, the Hill index, the Holbert logarithmic-based index, the Shannon index, the Sheldon index, and the Smith and Wilson logarithmic index, which was covered in episode 2. The logarithm-based indices that will be covered in subsequent episodes are all based on the Shannon index. And the Shannon index was created in 1948. So let's move on to the next slide. As I mentioned a few seconds ago, the Simpson diversity indices were covered in episode 1. Here in this slide, I have the Simpson diversity index, which is 1 minus the sum of all the frequencies squared divided by the total number of individuals in the organization squared. That also can be written as 1 minus the sum of p squared. And recall that the p represents the percentage of individuals in each category. A third way of representing the diversity index is going to be 1 minus the Simpson concentration or similarity index. And recall that in episode 1 I said that the Simpson concentration or similarity index is essentially the sum of the frequency of the number of individuals in each category squared divided by the total number of individuals in the organization squared. Or another way of saying that is the sum of p squared. And again, p, it represents the percentage of individuals in each category. And so the concentration score is essentially just the sum of all the p squares. There's also the unbiased Simpson diversity index. That's represented in this slide. And the unbiased Simpson concentration or similarity index is represented by the parentheses. So that's going to be the sum of the frequency of the number of individuals in category 1 through the last category times the number of individuals in that category minus 1. Once you sum up all of those products, you're going to divide that by the total number of individuals in the organization times the total number of individuals in the organization minus 1. You're going to get that whole product and subtract that from 1. that gives you the unbiased Simpson diversity score. The easier way of saying it is 1 minus the Simpson concentration score. Episode 1 and also in episode 2, the biased Simpson Evenness or standardized index was discussed, and the biased Simpson Evenness index or standardized index is the Simpson index divided by the number of categories minus 1 divided by the total number of categories. So if there are 2 categories, it's going to be 2 minus 1 divided by 2. That gives you the maximum value of the Simpson diversity index. So when you divide the diversity index by the total number of, by the sum of the maximum value, that gives you the standardized Simpson evenness score. Again, there are multiple ways to represent the formula. The first way is going to be 1 minus the sum of all of the individuals in each category squared divided by the total number of individuals in an organization squared. Divide that by the number of categories minus 1 divided by the number of categories. Another way of representing that is going to be 1 minus the sum of each percentage squared divided by the number of categories minus 1 divided by the number of categories. A third way of saying it is 1 minus the Simpson concentration score divided by the maximum score. So in addition to having the biased Simpson standardized score, there's also the unbiased Simpson standardized or evenness score, and that is essentially just 1 minus the unstandardized Simpson concentration or similarity score divided by the number of categories minus 1 divided by the number of categories. Those formulas are represented here in this slide, just very briefly. So one way to obtain the unbiased Simpson evenness score is going to be 1 minus the sum of the number or frequency of individuals in each category times the number of individuals minus 1 in each category. Divide that by the total number of individuals in the organization times the total number of individuals in the organization minus 1. And then to get the maximum score, again, it's going to be the number of categories, k, minus 1 divided by the number of categories, k. So together it's going to be 1 minus the Simpson concentration or similarity score divided by the maximum value, and that gives you the unbiased Simpson standardized or evenness score. In episode 2, which was posted last week, I covered the Smith & Wilson probability index and also the Smith & Wilson logarithmic index. This slide is a summary of the review of the Smith & Wilson probability based index, and this is it's going to be 1 divided by the Simpson concentration index. Once you get that product, you divide that by the number of categories, which is k, and that gives you the Smith & Wilson probability-based index. Another way of stating the formula is 1 divided by the sum of each percentage squared divided by k. And again, as I mentioned, it's going to be 1 divided by the Simpson concentration or similarity index divided by k. The 1 divided by the Simpson concentration or similarity index is basically the reciprocal of the concentration index. Another way of writing it that isn't represented here on the slide is going to be the Simpson concentration score to the negative power of 1 divided by k. In episode 2, the Smith & Wilson logarithmic-based index was presented. This is a quick overview. So to obtain the Smith & Wilson logarithmic-based index, it's going to be -1 times the log of the Simpson concentration or similarity index. Divide that by the log of the number of categories, k. Another way of stating that is going to be -1 times the logarithm of the sum of the percentage of each group squared divided by the logarithm of the number of categories or groups, k. Still, a third way is basically just 1 times the logarithm of the Simpson concentration index divided by the logarithm of k. Again, this was covered in episode 2, Also, the application of the indices cover the probability-based standardized index and also the logarithm-based standardized index. Briefly, the Simpson biased and unbiased concentration scores, diversity scores, and also the concentration scores are compared to the probability and logarithm-based Smith and Wilson scores. Again, because the Smith and Wilson scores are derived from the Simpson index, the concentration scores are presented for each index, the diversity score is presented for each index, and also the standardized or evenness score. And as I mentioned in episode 2, the Smith and Wilson probability-based index and the logarithm-based index produce scores that are lower than the Simpson-based evenness or standardized scores. The McIntosh index was created by Robert P. McIntosh in 1967. It is based on the distance measure of similarity. The standardized or evenness diversity score ranges from 0 to 1. It can be applied to qualitative-based data reported as frequencies or numbers and percentages. It is probability-based because it is based on the Simpson index. And again, it produces standardized or evenness scores. There are multiple ways to represent the McIntosh distance measure of similarity. One way is to square the frequency of each group or category and then take the square root of that number. So that will be, for example, 2 times 2, that gives you 4 for Asians. For the number of black employees, it's going to be 10 times 10, that gives you 100. And then all the way through to some other race, which is 3 times 3, which gives you 6. You add those up, and that gives you 10,000. You take the square root of that, then that gives you 78.41. You can also, like in the Simpson index, take the percentage of each group, or the percentage of each group. So for Asians, it's going to be 0.02. You times that 0.02 gives you 0.004. You do that for the percentage of the number of black employees in an organization. So that's going to be 0.1 times 0.1. It's going to be 0.01. And you do that for each other category until you get to the end, which is some other race, which is going to be 0.03 times 0.03 is 0.009. You add all of that up, that's going to be 0.610. When you take the square root of that, that gives you 0.781. So that is the McIntosh distance measure of similarity. Now, to obtain the McIntosh diversity index, it is very similar to the way to obtain the Simpson diversity score. So if we're using the frequencies, it's going to be the total number of individuals in the organization minus the square root of the sum of each frequency squared, or another way of writing it is 1 minus the square root of the sum of each percentage squared. Again, the sum of the frequency squared, that is the distance of similarity. It is also represented in the second part of the formula as the square root of the sum of the probability percentages squared. That's also the measure of distance. So when you subtract 1 from the measure of distance, if you're using frequencies, that's 21.859. If you're using percentages, that's 0.219. And again, that's the diversity score. Now, before calculating the Simpson standardized or evenness score of diversity, I want to cover how to calculate the maximum score for the McIntosh index. If you're using frequencies, it's going to be big N, which is the total number of individuals, minus the total number of individuals divided by the square root of the number of categories. So if there are 5 categories, as you see on the slide for ethnicity, the square root of 5 equals 2.238. So it's going to be, in this case, if using the frequency, it's going to be 100 minus 100 divided by 2.236. Another way of writing it, if you're using percentages, is 1 minus 1 divided by the square root of the number of categories, which is 5. So in the case if you're using percentages, it's going to be 1 minus 1 divided by the square root of 5, which is 2.236. As you recall in episode 1, this structure is very similar to the way the Simpson maximum score is calculated. So the maximum score for the frequencies is going to be 55.28. If you're using percentages, it's going to be 0.5528. Now in the McIntosh index, in this presentation of 1967, McIntosh also calculated a minimum diversity score for the data that is represented by an organization. So to calculate the minimum diversity score that's possible is going to be K times the number of individuals in the organization divided by K squared, and you take the square root of that. Another way of writing that is N, which is the total, big N, which is the total number of individuals in an organization divided by the square root of the number of categories. Still, another way to write that can be big N, the total number of individuals in an organization divided by K times the square root of K. And again, K is the number of number of categories. So I worked out an example for you. So if there are 100 individuals in the organization, divide that by the square root of K. So that's going to be 2.236. So 100 divided by 2.236 is that equals 44.72. If you're going to use percentages, then that's going to be 0.4472. Again, that is the minimum level of diversity possible for a particular organization with a set number of categories and a number of individuals for each category. So similar to the Simpson index, which was covered in episode 1, to obtain a standardized or evenness score, it's going to be the diversity score divided by the maximum value. So for the McIntosh index, if you're using frequencies, the standardized McIntosh score is going to be the total number of individuals in an organization, which is big N, capital N. Subtract that by the square root of each frequency of each category squared. And you're going to divide that by the maximum value, and again that's represented by big N, the total number of individuals in the group, minus the total number of individuals in the group divided by the square root of the number of categories. If you're using percentages, then to obtain the McIntosh evenness score or standardized score is going to be 1 minus the square root of the sum of each probability or percentage squared. Divide that by 1 minus 1 divided by the square root of K, the number of groups or categories. So here, as I mentioned in the last slide, the maximum value is 55.28 if you're using frequencies. If you're using the percentages, then it's 0.5528. The McIntosh diversity score, that is 21.39 or 0.219 if you're using the percentages. So when you divide the McIntosh diversity score by the maximum value, that gives you 0.365, and again that is the standardized, 3.85 or 95. The figures are small, so I can't really read them with my glasses. So that score is the McIntosh evenness score or standardized score, and again that's in this case is 39%. The organization obtained 39% with a maximum value of diversity possible. That's how you interpret that figure. So here in this slide, I compare the McIntosh diversity score and standardized score to the Simpson biased and unbiased scores. and also to the Smith and Wilson probability-based and logarithm-based indices. So let me talk about very briefly about the biased scores for the Simpson index. Recall that the Simpson concentration score, discussed in episode 1, produced a value of 0.611. When you subtract that from 1, that gives you the diversity score of 0.389. When you get the 0.389, divide that by the maximum value, that gives you a biased standardized score of 0.487. And again, that states that the organization obtained 49% of the maximum possible value possible. There's the unbiased Simpson score, and again, the unbiased Simpson concentration score is 0.607. When you subtract that from 1, that gives you the unbiased Simpson diversity score, which is roughly 0.393. When you divide that by the maximum value possible, that gives you a figure of 0.492. And again, that means that the organization obtained 49% of the maximum valuable possible given the unbiased formula. When you go to the second column, there's the Smith and Wilson probability-based index. Again, because it is based on the Simpson index, the biased the biased Simpson concentration score again is 0.611. When you take the inverse or the reciprocal of the Simpson concentration score, that gives you a 1.6. When you divide that by the maximum value possible for the Smith and Wilson index, that gives you 3.23 or 0.328. Again, that is the biased probability-based Smith and Wilson score of 0.328. When you use the logarithm-based index, again you're taking the same Simpson concentration score of 0.611. You take the logarithm value of the Simpson concentration score, that gives you 0.493. When you multiply that by a -1, that gives you a positive 0.493. Divide that by the maximum value, which is going to be the logarithm of the number of categories. That gives you the logarithm-based Smith and Wilson index value of 0.307. Again, for the McIntosh index, if you're using frequencies, the McIntosh similarity index is 78.141. If you're using probability, percentages, then that's going to be 0.781. The diversity score is going to be 0.289 if you're using the percentages. If you use the frequencies, it's going to be 21.859. When you divide the diversity score by the maximum possible value, that gives you a standardized score of 0.395. Again, that's for the frequencies and also for the use of percentages. So now that the McIntosh similarity index and diversity indices were presented, I'm going to apply the McIntosh indices to the gender data that was covered in episode 1 and episode 2, as well as to the ethnic data and the gender by ethnicity data, and also to the revenue data that was presented in episode 1 and episode 2, and that's to be consistent across all the episodes. So I'm going to use, again, the diversity score, the similarity score, and also the standardized McIntosh evenness score. As I mentioned in a few slides ago, I'm going to apply the McIntosh index to the gender, ethnic, and revenue data that was presented in episode 1 and episode 2. So let me go to share. So here is the gender data that was presented in chapter 1 and chapter 2. In this case, I'm going to apply the McIntosh similarity and diversity and ethnic indices to this data. Recall that I mentioned that you can calculate the maximum score, and you can calculate the maximum score for the frequencies or for the data represented in percentages. It's easier using the percentages because the numbers, when you use the frequencies, the numbers for some of the indices get extremely large, and it's just easier just using the percentages. But in this case, I'm going to show you how to calculate the maximum McIntosh score for frequencies. So recall that the formula is going to be the total number of individuals, big N, subtracted by the total number of individuals, divided by the square root of the number of categories. So to calculate the maximum McIntosh score for the gender data, let me click on the formula. Again, that's going to be F4, that's 100, minus, then parentheses, 100 divided by the square root of 4. And so when I use frequencies, that gives me a value of 50. When I use percentages, it's just going to be 1 minus parentheses 1 divided by the square root of 4. Again, this is going to be H5 in terms of the percentages. So that's going to be 0.50. Now to obtain the McIntosh similarity score, again, that's going to be the number of the percentage squared. And so the formula for that here is going for J5, which is the percentages. Let me click on the formula. It's going to be parentheses, power, parentheses, B5, which is 0.65, comma 2, which means to square it. So that is 0.65 times 0.65. Then here in the formula, and parentheses plus, parentheses power, C5, which is 0.25, comma 2, and parentheses, so that's going to be 0.25 times 0.25. And I do that for some other gender and for some other, and for unclassified. So I sum that up. So that gives me 0.490. To obtain the diversity score, it's going to be 1 minus the square root of the similarity score. So this is going to be 1 minus parentheses square root of J5, which is 0.490. So that gives me a diversity score of 0.30. Now, if I want to calculate the McIntosh evenness score, that's going to be K5 divided by I5, which is the maximum score. So this, again, here's the formula. 0.30 divided by 0.50 gives me a standardized score of 0.60. So that's an easy presentation on how to apply the diversity score, McIntosh diversity score to gender score. Now I'm going to discuss how to apply the McIntosh evenness score to the ethnicity data that was presented in episode 2 and in episode 1. Well, now that the McIntosh index was applied to the gender data, let me share the screen and let me go to the ethnic data. Again, this is the same ethnic data that was presented in episode 1 and episode 2. Recall that in episode 1, the Simpson indices were applied to this data. In episode 2, the Smith and Wilson indices were applied to this data. And again, I'm going to apply the McIntosh diversity scores to this data. Again, I'm going to just use the row number 5 that has the percentage data in it. So again, to calculate the maximum McIntosh diversity value for the ethnic-based data is going to be 1. Subtract that by parentheses 1 divided by the square root of I5, and in this case I5 is 5. So it's going to be 1 subtracted by 1 divided by the square root of 5. That gives me a value of 0.553. Again, to calculate the similarity index for the McIntosh index, it's going to be each percentage squared. And again, here's the formula. So for 0.05, the formula is going to be parentheses, B5 times B5 and parentheses plus, here I switch to the power. So it's going to be parentheses power, parentheses C5, comma 2, and parentheses, so that's 0.20 times 0.0. Then I did that for Hispanics, I did that for whites, and I did that for some other race. So you can use the power function in Excel, or you can just multiply the cell by itself. So that'll give you the squared value. So again, that's going to be 0.3250. And use the same formula for the frequencies. So to obtain the McIntosh diversity score with uses of percentage, it's going to be 1. In this case, it's going to be G5, so it's 1, subtracted by the square root of 5. So that's 0.430. So let me just repeat that again. So it's going to be 1 minus the square root of K5, and K5 is 0.325. It gives me a value of 0.430. So to obtain the McIntosh evenness score, it's going to be 0.430 divided by 0.553. So the formula is going to be L5 divided by J5. That gives me a product of 0.778. And again, I call evenness scores or standardized scores. That is 78% of the maximum value of the diversity possible was obtained. So now let me apply the McIntosh index to the ethnic diversity data that was presented again in episode 1 and episode 2. And let me go to share. So again, here's the data represented in a row. So here I have ethnic data by ethnic group. So in this organization, there are 5 Asians in the workforce. They are classified as male, female, some other gender, or unclassified. So the K is for gender is going to be 4. Again, we have the Black workforce consists of 20 employees. 13 of them are male, 4 are female, 2 of some other gender, 1 is unclassified. We have 15 Hispanics in the workforce with their gender distribution distributed across the 4 categories. We have 50 white employees. Again, their gender is classified across 4 categories. And some other race, which composed of 10 employees. So the K is 20. There are 20 groups across the 5 ethnic categories. So to obtain the maximum McIntosh score, again, it's going to be the total, which is 100, minus the total number of employees divided by the square root of the number of categories, or the number of groups, in this case is K. You can do that with the frequencies. We can also do that with the percentages. So with the percentages, it's easier. It's going to be 1 minus 1 divided by the square root of 20. That gives me 0.776, so that's the maximum. let me get the similarity score. In this case, I switched it a bit from the previous slide on ethnicity. So here what I did was I just, the formula equals the square root. Then I used parentheses, B5 times B5. And let me scroll over to that cell. So B5 is going to be 0.03. That's Asian males. So it's 0.03 times 0.03 plus the number of Asian females. So that percent is 0.02. So it's going to be 0.02 times 0.02 plus the number of Asians and some other gender group, which is 0. So that's 0 times 0. That's going to be 0. And then I do that for the Asians, percentage of the Asian workforce that's unclassified in terms of gender. So I do that for each ethnic group for gender. When I get the square root of that, it's going to be 0.410. Now to obtain the diversity score, it's going to be 1 minus the McIntosh similarity score. So in this case, it's 101 minus 0.410. That gives me a diversity score of 0.58. Now to get the evenness score, I'm going to get the 0.589 divided by the maximum score of 0.776. So there's the formula. So it's AF5 for the row, AD5, and that's the maximum value for the McIntosh score. So divide 0.5896 divided by 0.776. That gives me 0.759. And again, that's 76% of the maximum value of 0.776 was obtained by the organization with respect to gender by ethnicity. Now, again, to be consistent with the episode 1 and episode 2, I applied the McIntosh index across the rows for gender for each ethnic group. So here again, I have 3 Asian males, 13 black males, 10 Hispanic males, 34 white males, some other race, 5 males. It's a total of 65 males in the organization. So if I want to find the level of diversity for gender for males by ethnicity, again, I apply the formula to obtain the maximum value for the diversity score. It's going to be 65 minus 65 times the square root of 5. There are 5 ethnic categories. So that gives me a value of 35.93, and I am using the frequencies. Remember that recall that I said that if you use the frequencies, the numbers are getting extremely big, extremely large for the Simpson similarity index, and also for the diversity scores if you're using the frequencies. So here I use the power function to obtain the McIntosh similarity index. So again, that's going to be, let me click on the formula. So it's going to be 3 times 3. In this case, it's going to be power parentheses B4 comma 2. So that's going to square the 3. If I go to C4, which is the number of black males, so again, I use the power function, power parentheses C4 comma 2 and parentheses, that gives me the square value or the number of the frequency for the black males. I do that for the Hispanic males, do that for the white males, do that for some other race, and that gives me 1,459. Then in order to get the diversity score, it's going to be 1. In this case, it's going to be the total number of individuals, 65, minus the square root of K4, and K4 again is the similarity index, which is going to be 1,459. So that gives me a diversity score of 26.83. When I divide the 26.03 by the maximum possible score of 35.93. It gives me a evenness score of 74.746. That means that for male and race or ethnicity, the organization obtained 74% of the maximum value of 35.93. So I can do that for ethnic group by females. So I go through the calculations. Again, the maximum possible score for females by ethnicity is going to be 13.82. The similarity index is going to be 209. So when I get the diversity score is going to be 25 minus the square root of 209. That gives me a value of 10.54. When I divide 10.54 by 13.82, that gives me a value of 0.763, which means 76% of the maximum value was obtained. Again, I do that for some other gender by ethnicity. The diversity score for that, the standardized diversity score for that is 0.724, indicating 72% of the maximum value was obtained. In this case, the maximum value is 2.76. I can do that for unclassified. I can also look at, for each ethnic group, the distribution by gender. Again, I go to the formula. There's K categories or groups for gender. So the maximum score is going to be 5 minus 5 divided by the square root of 4. So the maximum value for the Asian group with respect to gender diversity is going to be 3. I use the frequency, so it's going to be, again, if I apply the formula, it's going to be 3 times 3. So it's going to be the power of parentheses B4, comma 2, and parentheses, and parentheses. So that's 3 times 3, plus 2 times 2, plus 0 times 0, plus 0 times 0. That gives me a similarity value of 13.00. In order to obtain the diversity score, is going to be the total number of Asians, which is 5, minus the square root of 13.0, B15. That gives me a value of 1.394. When I get 1.394 divided by the maximum value of 3, if I subtract the square root of the diversity score from the total number of Asians, which is 5, that gives me a standardized score of 0.558, indicating that 56% of the maximum value of diversity was obtained for the Asian work group. Again, all I have to do is just click on the formulas, drag it across, and again, for the total organization in terms of gender, ethnicity, the McIntosh standardized score is 0.60, indicating that 60% of the maximum value of 50 was obtained. Again, I can do that by gender, by ethnicity. You recall there are 20 groups. So the maximum value is going to be 100 minus 100 divided by the square root of 20. So that's 77.64. To obtain the similarity index, I have to square each cell and obtain the square root. So here I have to go 3 times 3, 13 times 13, 10 times 10, 34 times 34, 5 times 5 for the males for by ethnic group. I do the same thing for the females. Cross ethnic groups, that's going to be 2 times 2, 4 times 4, 4 times 4, 13 times 13, 2 times 2, and I do that for some other gender, across all ethnic groups, and do unclassified, across all ethnic groups. When I do that, I get the value of 41.04. To obtain the diversity score, that is a total number of the population, which is 100. Subtract that by the 41.04. That gives me a value of 58.96. When I get the value of 58.96, divide that by the maximum value of 77. It gives me a McIntosh standardized score of 70.759, which indicates that the organization obtained 76% with a maximum possible value of 77.64 for gender and ethnicity combined. Let me stop sharing. So that's how you apply the McIntosh indices to data that's presented in the contingency table by ethnicity, for ethnicity by gender. In this segment, I'm going to apply the McIntosh Evenness scores and also the diversity score to the revenue data that was presented in episode 1 and episode 2. Again, I'm doing this for consistency. This segment will include will apply the index to the actual revenue data, and also to be consistent with episode 1 and episode 2, I have a simulation or what-if scenario for revenue increases. So let me go to share. So here's the actual revenue data for this nonprofit that was included in episode 1 and episode 2. So I have, in terms of the revenue, I have $80,000 in corporate donations. That composes or comprises 20% of the total revenue of $403,000. I have $250,000 in individual contributions. That represents 62% of the total revenue. Fundraising is 45%, representing 11% of the total revenue. Investments is 10%, again representing 2% of the total revenue. Grant revenue is $18,000, and that is 4% of the total revenue of $403,000. So there are 5 revenue categories. And recall that I said that if you use frequencies, the numbers get extremely large. So here, when I apply the formula for obtaining the maximum McIntosh diversity score, again, that's going to be the total minus the total divided by the square root of total revenue. Excuse me, it's going to be the total minus the total revenue divided by the square root of the number of categories. So here we have 403,000 subtracted by 403,000 divided by the square root of 5. That gives me a value of 222,772. If I use the percentages, there's going to be 1 divided by 1. Excuse me, it's going to be 1 subtracted by 1 divided by the square root of the categories. So here it's going to be 1 divided by, 1 subtracted by 1 divided by the square root of 5. That gives us the value of 0.553. To get the McIntosh similarity score for the percentages, it's going to be each cell times itself. So I'm going to square it. So here for the percentage, it's going to be 0.20 times 0.20 plus 0.62 times 0.62 plus 0.11 times 0.11 plus 0.02 times 0.02, and finally 0.04 times 0.04. That gives me a value of 0.4393. When percentages are used, the McIntosh diversity score is going to be 1 minus the square root of the similarity score, so that's going to be 1 minus the square root of 0.4393. That gives me a diversity score of 0.337. When I divide the 0.337 by the maximum score of 0.553, that gives me a standardized score of 0.610. And again, this means that this organization obtained 61% with a maximum value of 0.553. Indicates that the level of diversity with respect to revenue yield across the categories is moderately good, moderately well. Then what I did for a what-if scenario, I increased the corporate revenue from 80,000 to 150,000, and that now represents 20% of the total new revenue. Individual contributions stayed the same at 250,000, and that now represents 47% of the total revenue. Fundraising I increased to 85,000 from 45,000, so that represents 16%. I increased investment revenue from to 15,000 from 10,000. So under this revenue scenario, investments represent 3%. I increased grant revenue to 35,000 from 18,000. That now represents 7% of the total revenue. And total revenue under this revenue scenario is $535,000. When I use the percentages, I get 1 subtracted by 1 divided by the square root of 5. Again, that's the same as it was above. So that's 0.553. That's the maximum value of diversity possible for the revenue yields across the revenue sources. When I obtain the similarity score, again, it's going to be the percentage times the percentage to square it. So here for the revenue scenario, it's 0.28 times 0.28 plus 0.47 times 0.47 plus 0.16 times 0.16 plus 0.03 times 0.03 plus 0.07 times 0.07. So when the product of the sum of the percentages squared, that gives me a sum of 0.3273. To obtain the McIntosh diversity score for the revenue scenario, is going to be 1 minus the square root of 0.3273. In this case, it's going to be K10. That diversity score is 0.428. When I take the 0.428, divide that into the 553, I get a standardized or Evenness McIntosh diversity score of 0.774, indicating that under the new revenue scenario, that the organization obtained 77% with a maximum value of diversity possible. And again, that maximum value is 0.553. And so if the organization obtains the revenue growth that is anticipated in the revenue scenario, it means that the revenue sources the revenue is very well distributed across all of the possible revenue streams. So that's the application of the McIntosh diversity score, standardized score, to the revenue data that was presented in episode 1 and in episode 2. Let me stop sharing. Now in the next segment, I'm going to cover very briefly, the supplemental or additional resources that are available to get a full understanding of the McIntosh Evenness scores. As I just mentioned, there are several additional resources that you can obtain to obtain a fuller understanding of the McIntosh index and the Evenness scores. One resource is the book which I authored, Assessing Organizational Diversity with the McIntosh Indices. or McIntosh index. That covers the similarity scores, the diversity scores, and the evenness standardized scores. The index is applied to primarily to data represented in percentages, just because it's easier to make the calculations. There are a lot of examples applied to gender data, ethnic data, and age data. The data are also analyzed with 6 different types of regression. It includes ordinary least squares regression, censored regression, Tobin regression. It has quantile regression. It also has rich regression and robust regression. The second source is assessing the validity of diversity indices. That covers the McIntosh index, the Simpson index, the Smith and Wilson indices. It also covers the Shannon index and other logarithm-based indices. The third resource is assessing organizational diversity with quantile regression, and that analyzes the McIntosh diversity scores that were presented in the earlier book, Assessing Organizational Diversity with the McIntosh index. So these sources are available. A resource that's also coming in August or early September is Assessing Organizational Diversity with Structural Equation Modeling. That applies the McIntosh index to data that's for the 72 New York City departments. That includes fiscal data, human resources data, includes turnover data. So that book should be out in late August or September. So I will put that on the future podcast and also on my Instagram, X, and Facebook accounts. So that'll be advertised on those social media accounts. So let me go next talk about the episode number 4. Briefly, episode 4 will cover the probability-based Holbert indices. There are 2 indices. There's the first is Holbert index number 1, which is based on the Simpson diversity index. So that index briefly is going to be the total number of individuals in an organization divided by the total number of individuals in an organization minus 1 times the Simpson index, 1 minus the sum of the percentages squared. The other index is a relative diversity index, again based on the Simpson index. So I will cover that. And remember, N, big N, capital N equals the total number of persons. The small p equals the percentage. And to be consistent with episode 1, 2, and episode 3, the data will be applied to gender data, ethnic data, gender by ethnic data, and as well as to the revenue data presented in the previous episodes.